go, here we go. Here we go, here we go, here we go, here we go, here we go. Here we go, here we go. Here we go, here we go. Here we go, here we go, here we go, here we go, here we go. Here we go. Here we go. Here we go, here we go, here we go, here we go. Here we go. Here we go. Here we go, here we go, here we go, here we go.
Hello and welcome to Containers from the Couch. I am Justin Garrison, and today with me I have Jimmy. Say hello, Jimmy.
Hello, Jimmy Ray here.
And we have special guest Porva here, who is going to walk us through a new announcement we had last week on what we call EKS Blueprints. So if you're using Kubernetes in AWS, we have some blueprints that help you get up to speed with running those clusters. So Porva, go ahead and say hello.
Hi, everyone. Apurva Kulkarni here. Nice to be here. And thanks to everyone who's tuning in and will be watching this later as well.
So tell us a little bit, Apurva, about what it is that Blueprints is, what problem is Blueprints trying to address, and how are you addressing that problem?
Yeah, sure. So EKS Blueprints it's an open source framework. So the first thing is it's available as open source. What we've found is that we want to make it easier for our customers to be able to deploy EKS clusters with the node groups, but also all the operational software that they need to run their clusters. And in Kubernetes world, these are commonly referred to as add-ons. So we make it easier for you to use our modules to define a blueprint, which would consist of the cluster, the node groups, and the add-ons that you want to add on top of the cluster. We also added some support for creating teams so that you can use your cluster to onboard multiple teams, basically use namespace as a service through the modules. And we'll show you in the following demo on how to do all that.
So, I mean, Kubernetes in the real world isn't complete by itself, right? Like you get a Kubernetes cluster and you need a lot of other things to make it kind of usable in a production style environment. And so Blueprints is allowing you to take a base Kubernetes cluster and then put on more add-ons for things that you might need, like deployments and some other settings and controllers that you might want, right?
Yeah, exactly. So if you think of add-ons, we have the EKS add-ons, which are the VPC CNI, the Core DNS, CSI, EBS CSI driver, kubectl, the ADOT add-on was recently announced as well. And then there's other open source add-ons. Like, so for Ingress, you want to have add-ons for accepting traffic from the outside world. So Nginx, load balancer controller, add-ons for observability, for example, Prometheus or FluentBit, AWS or FluentBit. And then there's other things like, for example, if you want to manage your workloads through GitOps, we added support for Argo CD today. And we have plans to add more there. So this enables you to kind of not only manage your add-ons, but also your workloads through a GitOps style workflow if you want to do it that way. You don't have to, but that's an option available as well.
So I had a question about the add-ons because I'm a little confused. These are not the same as the managed add-ons that are part of EKS, right? These are different, right? These are add-ons in the sense of the blueprints themselves, correct?
No, so in the case of EKS add-ons, which the managed add-ons that you're referring to, we actually use those. So okay. Terraform, has resources that you can use to, provision those add-ons on the cluster. So in cases where those add-ons are available through the service, we use that. We take advantage of that. And in other cases where it's an open source type of add-on, like Nginx, for example, those are the ones we create in the blueprint.
So, for example, I really when I'm building, applications that need an application load balancer, I'll use the AWS load balancer controller, and then I'll also use external DNS. And so I noticed that those are in your add-ons lister as well.
That's right. Yeah. So, in its vanilla state, we kind of have a default configuration that we think would be useful for most of our customers. But for all of the add-ons, you as a customer or a consumer of the module have the ability to override any configuration that we provide through, if in add-ons, it's all Helm charts. So you provide your configuration for the Helm provider with the values.yaml. And if you want to, for example, point it to a different chart repository or pull the image from a different location that's different from what the default Helm chart uses, all those things are configurable through that framework.
And these are the name implies these are blueprints. These are something that you can follow to kind of build this cluster and build what you need, but you can adapt that. You can change it. You can say, actually, you know what? I want 7 bedrooms instead of 5 or something, like whatever it is that you need for your environments, go ahead and adapt those. And that's really cool thing about how you've put these together, as these are modules that can either be used as the EKS add-ons that come with a cluster that you get that are managed, or you can have Helm charts or whatever it is you need. This is it. What we're going to review today is Terraform, which is great because that's what we see a lot of people that want it. They want to use Terraform. They're familiar with Terraform. There's a lot of extensibility with Terraform. And so we want to have that as a first-class citizen of, hey, here you go. If you want to see how we recommend doing this, here's the blueprint. Start here.
Yeah. So I just want to kind of clarify something, right? So there's the blueprints, which is a set of examples that we have built out in the repo. For example, like how do you use Carpenter with the blueprints framework. So the framework itself is published as a module. So for CDK, it's published as an NPM module. For Terraform, it will be published as a Terraform module. So there's the core module itself, which allows you to define a blueprint. And then a set of blueprints are provided as examples, as reference implementations for different use cases that customers commonly have asked for so far. So Carpenter using, there was a customer who wanted to deploy a Adonis game controller. And so, we didn't even think about that, but here's a customer that wanted to define their gaming use case using the Adonis project. So we have an example for that. We got an opportunity to work on that. We have an example for observability of using how do you provision an observability stack using managed Prometheus, managed Grafana, and OpenSearch, so that you can set up a blueprint to kind of have it available for app developers to start pushing their logs and metrics to AMP, AMD, and OpenSearch. So different examples are available, and we keep planning to add more as we go along, depending upon what the customers are looking for. Which serve as not only as reference implementations, but just if you want to take this and just rip our code and use it in your own implementation, that's totally fine. It's all cool, because our intention is to show what a good blueprint looks like when it comes to defining a platform use case for your Kubernetes cluster.
So with respect to consuming these blueprints, these patterns, it's going to allow the users to hit the ground running. With sensible defaults, but at later time they can also customize as they need to within the boundaries of the blueprint framework. And then my assumption is they can also contribute to this because it's an open source project.
Yeah, 100%. In fact, we want to try and build a community around it. Already, if you notice, we have 466 stars. So a lot of people are looking at the repo and have started opening up issues and feature requests. Because we've had this project out in the open source repos for a while until we announced the blog post. So we've been kind of doing all of our development in the open source. A lot of partners have been looking at the repo, and they have expressed interest in adding their add-ons as well. So we have a few partner add-ons that they've contributed their add-ons to the framework. So if you see something that's missing, open a feature request. We are happy to engage with you on what your use case is and get that added to the framework.
I think a great way just to get more of these question answers is to show it, right? We have a demo. We're going to show off like what you can do with it. And we have a whole workflow here. I do see a couple of comments about the GitHub repo. I do have a short link for it. I realize that in StreamYard, my comments don't go over to LinkedIn. So if you're watching from LinkedIn, hello. Sorry, the comments don't show up there. So if you come over to YouTube or Twitch, you'll get some of these comments showing up as well. But you can go to cftc.info/EKS Blueprints TF. And that's the full That's the URL for the main repo. I know there's a couple other ones, right, for add-ons and things like that, but the main repo should be able to get you started there. So let's go ahead and pull in your screen and shuffle this around, and we can show off the repo and how to get started.
Yeah, so getting started is basically, it's in the README, but in this case, I have a VPC already defined. So you're going to need a VPC to create an EKS cluster. So I've already used the Terraform module to create my VPC. And so I'm going to start at a place where I'm defining a bare bones cluster, right? So there's nothing on it except whatever default configuration that it comes up with. So I'm passing in the VPC ID and then a set of private subnets that the cluster will be using, and also a default configuration for managed node groups, right? So I have a minimum size defined. I want to define a certain type of instances, a node group name, just basic configuration that is expected for managed node groups. So like I said, I've already created this cluster. So if I do like probably get pod/a.
Really make that font bigger.
Oh, sure.
That's better.
So this cluster is already up and running with the default CNI, the default add-ons that it comes with, the EKS cluster comes with. So now I'm taking on a role of a platform engineer, right, or a platform developer. So I want to define what my cluster should look like for all of my application teams, applications that are going to be running on the cluster. So here is where I start adding add-ons. So I'm going to define a module called add-ons, and the source is the same as the EKS Terraform AWS EKS Blueprint. So it's under the AWS IR umbrella, Terraform AWS EKS Blueprint. I need to type properly. And then there's a submodule called Kubernetes add-ons. So this is where it's going to start pulling in the configuration for the different add-ons that we have enabled. And in order to use an add-on, it's basically a Boolean flag. So you say enable an add-on equals true. So one of the things that needs to be passed is called it needs the EKS cluster ID, so that the add-ons module knows like which cluster it's being used. So we just use the cluster ID that's available to us from the cluster that's already been defined. Blueprints. Right. So the first set of add-ons I'm going to add are the EKS add-ons, right? So these are the managed add-ons, commonly referred to, but these are the EKS add-ons. So enable Amazon EKS VPC CNI equals true. And similarly, enable Amazon EKS core DNS equals true, and the kube proxy. So by doing this, we are configuring managed EKS add-ons on the Kubernetes cluster. So I'm going to say Terraform init, and then Terraform apply.
And init's going to grab that new module, and now apply is going to look for the differences there, right?
Yeah. So then Terraform is going to have a typo there somewhere.
Is there a dash between add and ons?
No, hang on. I'm just going to copy paste the link.
So this kind of assumes that you build a cluster but you haven't added managed add-ons. I mean the core DNS, the CNI and the kubeproxy, they're there because they need to be there, but you haven't set them up as managed add-ons. So that's what you're doing here.
That's exactly right. Yeah. So we are basically we want to use the managed way of managing EKS add-ons, so that EKS does all the heavy lifting for me as far as management of the add-ons goes for those 3 add-ons.
Oh, good question here. Why not plan before apply? One of our show banners here is we do it live. You should always plan your Terraform runs before applying them, but Apoorva's a pro, so he's been working with this already, and for demo purposes, I'm sure knows it's not going to cause an outage.
Yeah, we want to spend less time, and there we go. So
see, even with auto approve right there, that's just like YOLO. Let's go. Let's. I saw another question here about if you already have an EKS cluster using open source Terraform modules, should they be switching to Blueprints? How would we recommend them, adopting some of the benefits of Blueprints with these, sort of flexibility and add-ons with their own existing Terraform code?
Yeah, that's a good question. So we actually use the upstream, the Terraform AWS EKS modules to define our cluster. So if you go to the main.tf, which is our main Terraform file, you will notice that we actually use this module to define our cluster. So the advantage you get when you use our EKS Blueprints module is that you get the additional functionality of defining the add-ons, right? So you can continue to use your usage of the upstream module. If you want to take advantage of the Kubernetes add-on, you can directly invoke that through the submodule approach, and you don't have to change the way you do it, but you do have to pass in things like cluster ID and cluster authentication parameters and so on. But at this point, it depends on your use case. If you see that there are some features that you can take advantage of by switching over to EKS Blueprints, you may wish to do so, but you don't have to. Undeclared resource.
Oh, is the ID not?
There we go. Module. Is it module? Yeah. Isn't it? Yeah. That goes all over the place.
Live coding.
I can't type when someone watches either. It's fine.
Yeah.
We're good. We're good.
Yeah.
Everybody does it.
There we go.
There we go. Another question here about managing upgrades and updates. How does that work within Terraform and with the cluster themselves? Like manage add-ons is managed by EKS control plane, not by the Terraform code, right? You don't need to specify a version, but there are other add-ons that you're going to want to define.
Yeah. So if we look at upgrading, overall, it's kind of broken down into upgrading the control plane, upgrading the node groups, the add-ons, and then your applications. So we don't have a good doc for it yet, but we're working hard on it, on how do you do managed upgrades through the blueprint. So we will provide a detailed documentation on how you can do that. It is possible. We just haven't documented that today yet, but that's something that should be coming up soon.
But you pointed out some really good idea there that folks need to understand is that you've got multiple things that are somewhat separate with regards to upgrading the control plane, the node groups, the add-ons if they're managed that way, and then your applications. So
right, and we have a blog post on that. I think was out a few months or a couple of months ago on that defines on how you think about that process. It is a multi-stage process. And so what we want to do through our documentation is to make that process a little bit simpler through the framework. But there's always, the part where the applications have to be upgraded as well to match if they're consuming any Kubernetes APIs. And so that we'll make sure that we capture that use case as well. So if you do get pods now, we should be able to see that the EKS add-ons are up and running. Cool. So success. So now that we have defined EKS add-ons, let's define Ingress configuration. So for that, we will take advantage of Nginx equals true. And Nginx needs a network load balancer. And so we take advantage of the fact that we can provide some annotations in the Nginx values.yaml, which the Nginx controller uses to provision a network load balancer. I have also pre-created an ACM cert so that I can terminate my TLS traffic on the network load balancer. And I also have a public-facing Route 53 hosted zone so that app teams can just provide, like, I want to use a host name foo, and then bar.com is already configured to be terminated on with ACM to be terminated on network load balancer, and then the service just starts accepting traffic on that particular host name.
All things you can easily do in Terraform. They're just not the focus of the Blueprints framework that we have here. So if you want to do those things, add your own modules for that in Terraform, and you can handle that as well.
Yeah.
Absolutely. And important to note here, the Ingress you're defining isn't a managed add-on. This is an external add-on via Helm chart that you're deploying into the cluster, and you're adding those annotations so you can pull in these other add-ons that we're using the same word add-ons over again, but it is something that's separate than what is actually managed within EKS itself.
That's exactly right. Yeah. So these are, now we're getting into like Helm managed add-ons, right? So these are the add-ons that we provide in the framework today. There's a list of them, and you can kind of browse through that directly based on like stuff customers have asked for so far. Highly encourage everyone who's watching to kind of take a look at that and see if there's something that's missing and something that they want to use as a EKS Blueprints add-on, and we will be kind of happy to work with you on getting that added there as well. And it's a great opportunity for someone to contribute an add-on as well, because add-ons is one of the easiest things you can add to the repo. We have a very well-defined way to do that. It literally, if you have a Helm chart available, it literally takes somebody who knows Terraform not more than a day or two to create an add-on, and provide us with a PR. So, and what I'm doing here is providing a values.yaml and overriding that values.yaml with my configuration for DNS and ACM. And that's it. And so I'm going to go ahead and apply that once again. And so now Blueprints is going to template file. Right, Blueprint is going to configure Nginx, load balancer controller, an external DNS with a default configuration, but we are overriding the Nginx values.yaml with a host name that we want to use, which is a private host name that I've already configured, and an SSL cert for my for termination of TLS on the network load balancer.
Another good question came in here about support with CDK. I want to use Python CDK, similar thing. I know we have a separate repo for that. There's a whole separate process for if you want to use CDK versus Terraform.
Yeah, that's right. I have the link up here. This is available in the AWS Quick Start organization. It's called CDK-EKS-Blueprints. It's very similar to the Terraform version, that the kind of two side-by-side projects. We publish an NPM module for this in the NPM registry. So they both have teams that are core to them. So we handle pull requests and issues that show up in very similar fashion on both Terraform and CDK.
There's that link. Found it.
Oh, yeah. So it needs one more thing right here. EKS cluster domain and this. So while that's coming up, going back to the add-ons repo, right? So talking about contributing add-ons, we have created what's called as a Helm add-ons. This is like a generic Helm module, Helm add-on module that's written in Terraform. So we provide an interface for contributors to be able to just take advantage of this add-on. So we have typically when you deploy a Helm chart through Terraform, it needs a certain set of things. Along with that, like for every add-on, you have a chance to define a configuration for Ursa, right? So for example, for add-ons where we've created them for AWS resources like the load balancer controller, we define a default configuration for Ursa. So all the
Can you make the font a little bigger? And just for anyone not familiar with Ursa, is an acronym for IAM roles for service accounts, and so it allows you to tie a Kubernetes service account directly to an IAM role. And so it's a process within a cluster, uses OIDC to then map those two things together. So you don't have to do something like Cube to IAM or these other controllers that run in the cluster that kind of download a bunch of IAM credentials on a node. You do it per pod and per service account. So just clarity for anyone else.
And the policies you need are well documented in the add-ons that we provide. So we basically just grab hold of them, and these are best practices that have been defined by service teams in most cases, and we add them to the add-on. You can also provide, in addition to Ursa, you can also provide IAM permission boundaries. So if you have permission boundaries that you define in your organization, you can provide a permission boundary. We will apply that for all the Ursa roles that we create.
So with respect to this process, let's say they already have a set of roles that they want to use for this, you could, I guess they could define those, or how would that work?
No, we define the Ursa roles. If you want to provide additional policies that you want to apply, you can provide them.
Okay.
But we, in most cases, for the add-ons that we've created, which are, in most cases, these are like AWS add-ons, right? So load balancer controller or something like that, where we know that the add-on is going to need access to a certain set of resources. The service team or the repo where the add-on comes from has defined policies that should be used with that add-on. So we define that for you. So you don't have to think about what are the permissions that are required for this add-on to work. But having said that, if you have a certain policy that you want to apply, because maybe you want to give some additional permissions to the add-on, that's possible to do in most cases, where you can provide an additional set of policies for the add-ons, and we'll apply that. Cool. So our Nginx load balancer controller and external DNS should be up and running by now. And yeah, looks good. Sweet. So the next thing, as a platform engineer, again, I'm defining what my cluster should look like. So I want my developers to be able to observe their applications. And in this case, I'm going to be using AWS for Fluentbit for logs, set that to true, and then enable AWS CloudWatch metrics as well. And so basically, this is container insights getting configured here. So again, applying that and let that run. But like I mentioned before, I'm bringing up Container Insights right now, but we do have support for Prometheus as well. And we're working with the ADOT team as we speak to kind of get an add-on for ADOT created as well. ADOT EKS ADOT add-on was just announced a couple of days ago. So we'll actually enable that through one of these managed add-ons. So you would be able to say enable Amazon ADOT something equals true, and then provide a config for your collector, and then we will just apply that through the framework as well. So your observability stack through ADOT will be configured through the Blueprints framework. So in the spirit of defining what a blueprint should look like for an observability stack, you can do that through the framework. And so our logs and metrics are now flowing in through the through Flow Embed and through CloudWatch metrics into CloudWatch.
Yep.
Cool. So now that we have defined, so this is our blueprint, right? So let me kind of zoom out a little bit just so we get a single pane of glass view. So we have EKS add-ons, we have Ingress, and we have observability. So let's assume for this demo, like this is what my cluster configuration should be from a add-on perspective. And now I need to start onboarding some teams. And so I'm going to start defining what those teams need to be. So the first team I'm going to create is called as a platform team. And a platform team gets administrative access to the cluster. And so the way you define any team is to provide a set of users, which are essentially IAM arms. So it could be an IAM user or an IAM role. Behind the scenes, the add-on will create a role, configure Kubernetes RBAC so that any IAM principal that has access to that role would be able to access the Kubernetes cluster using that credential. So if it's a platform team member, they get admin access to the cluster. If it's an application team member, like we'll define now, they get access to a namespace, and they won't be able to access anything else within the Kubernetes environment.
And is this managing the AWS auth config to be able to do this?
That's exactly right. So we configure the AWS auth config behind the scenes, and the Kubernetes RBAC as well.
So under the covers, if you're creating a team and they're going to have, let's say, namespace scoped permissions, are you creating namespace scoped roles and role bindings, or are you also doing like cluster roles with namespace role bindings? So you get both uniformity as well as namespace isolation.
So we do both cluster roles and the role binding. So you get complete isolation on the namespace. You're not able to do anything else outside of the scope of the namespace. So when you create an application team, you're expected to provide a set of labels and quota at the minimum. We want to hear from our customers and anybody else who's using this framework on, because this is every organization do things differently, and we want to capture some use cases on how customers are using multi-tenancy on their clusters. Today we have support for two kinds of teams, but if you have a particular use case where you want to define, for example, like a security team or an audit team, let's discuss that through issues, because we want to make sure that we provide you some flexibility when it comes to defining teams. This is an area where we are, trying to figure out like what are customers doing, what do people want to do here, and so.
So for example, let's say they're creating a namespace, and let's say they want to stamp that namespace with a set of network policies that locks the namespace down until they start to populate their applications within the namespace. Or maybe maybe they're soft multi-tenancy, like we describe in the EKS best practices guide. Maybe they also want to augment that with isolating their pods onto namespace specific compute. I'm assuming you can do like node affinities and taints in here as well, or?
Yeah, you can. So for teams, I forgot to mention, you can pass in just Kubernetes manifests, right? So for example, policies that you want to enforce for a particular team. And we have an example of that in the repo. I'll pull that up. But if you want to apply network policies and any other policies, you can provide a folder where you have all those policies defined in Kubernetes YAML, and we will apply that for you when we define the team config. And then pods 100. And so again, like these are quotas. So you can imagine, like in a large cluster where lots of teams are running, you want to be able to restrict them to be through quotas. And so we provide a way for you to be able to do that by defining this quota config. These are just arbitrary set of values. You can map these to whatever values you want to provide for your teams. And so as we apply that, again, behind the scenes, we're going to configure platform teams. There we go. So behind the scenes, we're going to create the IAM role, configure Kubernetes RBAC, and provide a way for you to be able to configure your local kube config as well. So what I actually didn't type, what I should have is an output, right? You want to be able to provide an AWS CLI that your team members can just run to configure their kube config. And so we have that in the form of an example here. So for example, it's output, platform, team kube config, and that would be module.EKS Blueprints, teams, platform teams, configure kubectl.admin, which is the name of our team. Looks like there was a failure. Oh. Finding a double list. There you go. So I was talking about the example where we show how to configure multi-tenancy. If you go to the examples, within the examples under the EKS Blueprints in the repo, there's an example for multi-tenancy with teams. And here we show like how you can configure two teams, team red and team blue, and apply a network policy, for example. And so any kind of policies that you define will be applied through the framework when you create those teams.
Here's a good question about the Helm chart flexibility. In this case, asking if you can have two of the same chart essentially installed. They have external DNS for external public traffic and internal private hosted zones. Is that something you'd be able to do with Blueprints add-ons?
Can you repeat that question again? Sorry, I was distracted.
Sorry. I'm still getting over something too. Sorry. Question about Helm chart add-ons, the flexibility. In this case, someone has external DNS. They have two installs of external DNS, one to manage public hosted zones and one for private hosted zones. Is that possible with the Blueprints add-ons to be able to have the same chart deployed twice with different config?
That's a good question. I'm not sure if that's possible today. You cannot do that today. I think there might be some issues if you try to do that. If anybody from my team is listening in, if they're available to provide a comment on that, but I don't believe that's possible.
At minimum, we'd love to hear in a GitHub issue. Go ahead and open an issue for that.
Yeah.
And
that's an
see if
interesting.
we can't figure out how to.
And along those same lines, in practical usage, a lot of folks are using external DNS to mutate centralized Route 53 records. So, not necessarily in the same account. So, that would be another use case I'd be interested in.
Right. I forgot to define a name for the team in my rush to get it out there. All right.
You're doing a lot more live typing than we typically have. So kudos to you.
Well, I want to show like what the experience is and how quickly it is possible to define these things. So yeah, I forgot to provide a name for the team. So basically an application team called Team Riker has been created. And so namespace with that name will be created, and then all that our second config will be applied there as well.
So something to point out real quickly here is what you've been doing kind of illustrates how you can use this tool to prototype your approach to building clusters. Being able to work with this stuff on the fly, and let's say in a sandbox account or something, and make sure that you've proven out what you need to do, and then set this up as the default blueprint for your clusters going forward.
Right. Exactly. What am I doing here? So I've got users. Oh. Hang on, I need to reduce my font. It's too big for my. So I've got this. Okay. Hopefully that should do it. Always fun debugging live. This is an instance where I actually just copy pasted the sample code I had. It's a lot of indentations that I need to think about.
I mean, the examples that we have in the repo too are just amazing to be able to like copy and paste little snippets of like, here's the example you want. Here, just go to this example and find the use case. And like I was using the carpenter example like a week ago, and I was using like all these other things. I was just like, oh yeah, this is the exact same thing I wanted. Let me just plug it into the rest of my modules, which is one of the big benefits of Terraform, where by using HCL everywhere, you could just kind of copy and paste these things and say like, oh yeah, I just need extra data, or I need to config something, override something. It's easy. Yeah,
there's some really good use cases here. For example, like one of our team members was working with a customer who's defining, how to run Spark on EKS. And so if you have those kinds of like big data use cases where you want to be able to run Spark jobs on EKS, we have a really good example for that. If I'm not mistaken, it uses Carpenter to kind of, as Spark needs worker nodes, as they need to scale up and down, Carpenter is amazing to be able to like just bring up Spot instances or on-demand instances and then just run those pods, the worker jobs on those instances, and then just bring them down when you no longer need them. And we have a really good example for that. Okay, finally, here we go. So once again, like I have platform team, and I should be able to just give this command line out to a platform team member, and they now have admin access to a cluster. And in similar fashion, I cannot put the kube config for an application team member, and if they were to run the command, they would not be able to see all the pods. They can only see what's happening within the namespace. Awesome. So we have defined a team. Now let's go ahead and start onboarding workloads. Justin, before we do that, like how much time do we have? I don't know if you want to.
We got about 10 minutes.
Okay. Cool. So in order to onboard the workload, we support GitOps through Argo CD today. So again, like source is the same Kubernetes add-ons module here. I'm going to copy paste that because I don't want to type the full URL. And then EKS cluster ID is again module EKS Blueprints.EKS. And then enable Argo CD equals true. So this will enable Argo CD add-on. So we have again a default configuration to run Argo CD. If you want to override that and provide your own configuration, and you can override the values of YAML that we use by default. And then for workloads, it's Argo CD applications. So this is a configuration, Argo CD configuration for creating an app of apps, right? So in Argo CD, there's an app of apps pattern, which lets you define an Argo CD application, which then further lets you further configure sub applications, applications that are going to be a part of that team or workspace workload within your cluster. So I have a sample available under this repo, which you guys are kind of free to take a look at. It's open source. We also have an upstream repo for this as well, which we are kind of working to provide more examples of more complex use cases. So if you look at the Argo CD sample apps repo, they have really good examples on how to use Helm or KSonnet or Customize to define your Argo CD applications. So over time, we will provide more complex examples as well on how to do if you have these complex patterns within your use cases, you should be able to use them as is. So you just point it to a repo that has the application definition, and Argo CD will just work its magic and pull those down for you. And again, in this case, what I'm doing is providing a values, and I want to provide a values is essentially a config for Ingress for those services that will be defined by the app teams. So all I need to do is provide the host name that those apps should be using. So for example, I'm going to be bringing up an application called Guestbook. It's a popular open source application that's used for demos. So guestbookui.bar.com. And all I need to provide is bar.com, and any service team will be able to provide their service name, and Nginx will configure load balancer and external DNS with that. Okay. So enable Argo CD, provided a configuration for workload, pointed to an Argo CD application repo, and provided a values with the host name that I want the apps to use. And so while that's coming up, I'll pull up the repo. Do we have any questions, Justin?
I saw one more. I think we kind of answered. Is asking if Blueprints is creating the namespaces as part of the add-ons or as part of the teams. And yes, I don't think you listed the namespaces, but the configuration we added to that essentially limited that namespace to a certain number of CPUs, memory secrets. So that team had a confined box that they could work with, and then also the command outputs for that team to automatically generate their kubeconfig file would essentially give them the RBAC required to do whatever they need within that namespace.
Yeah, and that's just the additional capability. If you just want to have, like in this case, like for example, if you just want to have your app teams interface with Git and nothing else, that's totally fine. That's your operational model. We just provide a way for you to be able to, if you want to give access, here's how you can do it.
You're breaking up a little bit
So,
there.
so
I think your Terraform applies stealing all your bandwidth.
yeah, that's possible. Okay, so while that's coming up, I also want to quickly point out to this repo. It's called EKS Blueprints Add-Ons. So when we talk about add-ons, there's essentially two ways to manage your add-ons today and through the Blueprints framework. One is like if you want to do everything to infrastructure as code, so it's all Terraform. You're essentially turning on those add-ons, and then if you want to override any values.yaml, you provide that through a values.yaml through Terraform, and it gets applied through Terraform. But we have heard of customers who want to bring up their AWS resources, so the cluster and the node groups to Terraform, and then manage all of their add-ons through GitOps as well, right? So these are customers who want to do everything on Kubernetes through GitOps, everything on AWS through Terraform. And so this is a repo that we provide as an example, as a reference, where you can do that for add-ons. So there is a flag which says enable Argo CD managed add-ons equals true. And if you provide that add-ons when you're creating your add-ons, all the add-ons now are going to be managed through GitOps. So none of the Terraform like thing holds true anymore for add-ons, because now you're turning on Argo CD and you're pointing Argo CD to an add-ons repo, and the add-ons repo has charts, configurations for all the add-ons. And so these are like, for example, just a random example for FluentBit. Here is a definition for an Argo CD application for FluentBit, and then under add-ons, it would be the actual FluentBit add-on that we pull in, with an ability for you to override the values.yaml. So if you want to manage your add-on through GitOps, manage everything through GitOps, you create your own values.yaml, you provide a default set of values that you want to do. Anytime you make a change, you're using GitOps to change the configuration for add-on. Terraform is not involved at that point.
Yeah, and that's an important thing to call out that a lot of people get confused on is the different ways you want to operate depend on who you want or what system you want controlling that state. And so one system should be responsible for the actual state of the cluster. And you can do that through GitOps with either Argo CD or Flux. You can do that through Terraform directly by running these commands like we're doing here. You can do that through EKS Add-Ons, where EKS actually manages the add-on states. And so there's different ways that you can apply this. And so you have to make sure you pick which one you want, which one you're familiar with, and which one kind of works with your process and teams that's inside your company.
Yeah, exactly. It all depends on like what kind of operating model you have within your company. And we have customers who do both. There are customers who want to do everything to Terraform, and then we have customers who want to do AWS resources through infrastructure as code, like Terraform or CDK, and then add-ons through GitOps. And both are valid models to operate.
Yeah, the one thing I always recommend is just find the thing that you understand the most and start there. Because at some point, you're probably going to have to dive into the state. If something has a conflict or something, you're either going to have to go to the TF state files, or you're going to have to go into CRDs and Kubernetes and YAML and figure out which conflict you're kind of resolving. And if you're not familiar with it, you can cause more problems. So try to find the one that you're familiar with, that your team has some expertise in, and start from there. And then go on to saying like, oh, hey, if there's a limit of that system, try another one and see like, okay, GitOps has a lot of benefits over traditional infrastructure as code, sort of Terraform apply only when code changes. GitOps is always going to be maintaining that state. So figure out what works for you.
Exactly. And so just on that, like we have an example on how you would go about doing that in the repo. If you want to manage your add-ons through Argo CD as well, we kind of use the repo I showed earlier, the EKS Blueprints add-ons, as a reference example. And the flag I was talking about is essentially this one. So Argo CD manage add-ons equals true. And once you set that to true, all the add-ons are expected to be managed through GitOps. This thing's still coming out. Almost there. There we go. So now Argo CD with all of its pods is up and running. One thing I forgot to do was provide a configuration for admin secret, but I'm just going to patch a password for it so that I can actually bring up the Argo CD UI in my browser. And I'm going to use the kubectl port forward to forward the remote Argo CD service onto my local host.
So I wanted to ask: is this part of the blueprint would automatically create the network plumbing as well? So the load balancer in front of Argo CD, so that you can access it.
No, we don't have a configuration for that today, but you should be able to define that if you wish to do so, like through a configuration for like override our values.yaml and make it use the ingress to load balancer controller. Okay, so Argo CD workloads app has my app for Team Riker. And
can you make that bigger?
Sure, sorry. I always forget that. Is that good?
I can almost read it.
Okay. Yeah, so this my workloads app already has the definition for an application guestbook. And so when all I did through my Terraform code was define where my Argo CD app is. And there it has all the Kubernetes definition for bringing up my application. And so because we have already provided configuration for Ingress, like network load balancer, DNS, all that is already configured. The app teams didn't have to know what those settings need to be, right? They just need to say, I want to name my service Ingress guestbook UI. And so now when I go to guestbook UI and this is like the full host name, the app is up and running, right? So they didn't, as an application team, they didn't have to be concerned with how should I terminate my TLS on the network load balancer? What DNS hostname do I need to use? And this is just standard Kubernetes, but we make it easier for you to be able to do that through the EKS Blueprints framework. And Justin, depending upon the time, I have like one more thing to show, but I'll let you.
If you can fit it under 5 minutes, we're good.
Okay, sure. So like talking about like application developers and how do you onboard an application. So I have the namespace defined. I have a team defined. I have Argo CD application, Argo CD already looking at my workloads repo. So now this is the standard Argo CD stuff. So I have a branch where I have a new service called Echo service, right? The Echo server. I'm going to push that. So this is the workflow where as an application team, I don't need to know anything about Kubernetes. I'm just going to open a pull request into my workloads repo and try and onboard that app into the cluster. So it's coming up. So this is the pull request. A bunch of Kubernetes YAML with the Ingress definition that uses the same Nginx, defining the name of my service, and the value is the value for the host name that the domain name is pulled from values.yaml. I don't need to know what it is. And once I create the pull request and merge it, Argo CD should hopefully, kind of make that service run in my cluster.
And this is working in the background because of the whole app of apps pattern that you adopted as part of your Argo CD.
Exactly. And this is just a way for defining different services. In the interest of time, I'm going to sync manually, but it should, like, if we had enough time, Argo CD will eventually reconcile and realize that there is something else there that I need to deploy. And so now Echo server is deployed. If I go to echo server dot, maybe not, DNS propagation. Yeah, the service is up.
Time to dig.
Try to force it, just coax it a little bit. Don't do this at home.
Always comes down to a host file.
There you go. So an example of like how we onboarded an application into the cluster without interacting with without using kubectl or any of that. It's just using Argo CD workflow to onboard application into the cluster. One last thing I wanted to show was the observability that we spoke about. So we do have Fluentbit and CloudWatch metrics running. So if we look at container insights, let me blow this up again, and look at the container map. I like this view a lot because it kind of gives me a holistic view of what's in my cluster. Let me blow this up. So all of my apps are already kind of in there. Oh, let me filter by clusters, sorry. There you go. So you can, a single pane of glass view, you can see all the different parts that are running. My applications, observability is enabled for them, so I can kind of drill deeper if I wanted to. So we brought up Echo Server. Metrics are flowing in. We can start looking at alerts and logs and all that good stuff. I want this to be a container insight sessions that probably warrants its own thing, but just wanted to show that, again, like app engineers didn't have to worry about, hey, how do I monitor and log my application? Because that's already defined for me by the platform persona. I just bring up my application and logs and metrics are already flowing into CloudWatch. And you can do the same with Prometheus and any other stack that we have so far. And so that's all I have to show. I don't know if there are any more questions, Justin, that I can help answer.
Yeah, we got quite a few more questions, but we also have time. So it's a little bit, I want to get some of these people in here, but feel free if you have questions on the code itself or what you can do with the repo, go check it out on GitHub, open an issue if there's something that you want an example for that you can't figure out how to do or want to be able to do. Things like, multiple DNS is a use case that I already brought up. So I think this is all great suggestions and things that we can pull in the code, whether that's extra configuration in the add-on or directly in the main blueprints itself. And so some of the things like Carlos is asking about is OTel part of the blueprints, and like we're working on that one. That
very soon.
That add-on was just like last week, so we're getting a few more things. But again, like we have the generic Helm chart add-ons as well. So if you're something that like, hey, I just want to add this Helm chart, you have an internal repo or something, like you can onboard that into Terraform, especially if you're already doing Helm charts with Terraform. There's no like magic sauce here. This is using a lot of the open source repos combined in a way that is structured so that we can build clusters that have multi-tenancy for within the same company and team, and some of those niceties of just like, how do I map the IAM user to an RBAC user?
Yeah, absolutely.
So this is a great overview going from bare Kubernetes all the way to like application teams don't even know Kubernetes is there necessarily. I thought that was a great flow of just like development platform team to where's the app team going to interface with this. And if it's Argo, that works. I know Flex is coming. It's the request already for Flex as well. If you have Jenkins, something else, like it depends on what you're using. There's a lot of different options out there to get apps deployed to Kubernetes.
Exactly. Yeah. If you have anything that you want to see in the examples, we're looking for more use cases that customers are using today with EKS, and so let us know. We're more than happy to work with you on getting those added.
I think the last question I'll bring in here from Eve is it possible to migrate existing clusters to be managed by this module?
So there's nuances to that. The answer is mixed. Yes and no. You can bring in an existing cluster, but we won't be able to manage the cluster, but you can manage the add-ons on top of it. So if you want to use it for just pure add-ons, that's fine. But we won't be able to do anything with the cluster today.
Yeah, you have to import that state of the cluster into Terraform. And if you already created it with CloudFormation or through the console or something, that's not a pretty like a one-to-one sort of thing you can do. Right. So if you're making new clusters, give it a try. There's tons of examples out there. You can just add a couple variables and Terraform apply, and you should have a cluster.
Yeah, exactly.
So thanks everyone for coming. Thanks for watching. And Apoorva, thank you so much for the demo. This was great. Go ahead and check out the repo, and we'll have more videos. I know there'll be more blueprints in the future too. So
Yes.
subscribe if you're not already, and hope everyone has a great day.
Thanks, everyone.